So hi and welcome everybody. Welcome back to the course of computer networks. In today's lecture, in this section, we are gonna talk in more details a little bit about physical layer and then move on to talk about other important topics related to switching and framing. So physical layer, as we explained before, is one of the most critical layers in the OSI structure, in the OSI protocol, in the OSI reference model, sorry. And if you were to visualize in your head what happens when you want to send your voice call, your voice message, your voice to your friend who's far away from you 100 kilometer, then you produce this voice message, which we call here the information source. The information source here is your voice. It can be sounds, music, pictures, words, codes, light, temperature, pressure, anything. This is the information source that you want to send. You convert this analog signal that exists in nature into an electrical signal via a sensor or a transducer. So this transducer basically converts the analog information to an electrical signal. So the electrical signal will become like a representative of this analog information. The electrical signal, then you process it and you then modulate it, you shift it to a higher carrier frequency, and before modulation you encode it to protect it from transmission impairments, and then you send it through the air. It passes through either wireless or wired channel, and then at the receiver job is to detect this electromagnetic signal and convert it to electrical current or electrical signal, and then demodulate it and decode it back. Then it passes it to transducer, which is kind of a block that's responsible for converting the signal from quantized, digitized form to an analog form that the human can read or understand or see. So, example of on information source, you can consider human being communicating over a line or machine or nature itself. Example on transducers that convert analog signal to electrical signals is microphone, camera, scanner, LDR, piezoelectric, thermocouple, thermistor, pressure, ultrasonic. All these are examples of sensors that convert your analog signal into electrical signal. This is the job of a sensor. Convert it from something that cannot be understood by electronic circuit into electrical signal that can be read, understood, analyzed, quantized, digitized, and encoded then. And then convert it to, then try to transmit it over a very long distance through a process called modulation. And the reverse process happens here. So the physical layer in general, it's responsible for reliably transmitting bits over a medium. Services provided by the physical layer are listed below. This list is not exclusive. I'm not mentioning here all the functionalities of the physical layer, but these are some of them. First, physical characteristics of the media. Encoding and decoding, modulation and demodulation, representation of bits, how to represent them, with which line of code. Data rate adaptation according to the environment and variations of the channel. Synchronization of bits, line configuration, physical topology, and transmission mode. Let's start with line configuration. What's line configuration? In a network, two or more nodes are connected by a communication link. The communication link can be wired or wireless. For visualization purposes, links are imagined as a line drawn between 2 points. So inside the Cisco Packet Tracer that you have downloaded in your PC, link is basically this part connecting your PC with router and your router with a switch and switch with laptop. Each section here is a link. This is communication link. You need to configure it from both ends, from both ports. from this end and this end. You need to give it an IP from the laptop side and router side. For communication to happen, two nodes must be connected to the same link at the same time. This is called line configuration or connection. This is what happens in line configuration. Now, what are the types of line configuration? There are two types. The first one is point-to-point connection. The second one is multi-point connection. What's point-to-point connection? A point-to-point connection provides a dedicated link between two devices. The entire capacity of the link is reserved for transmission between those two devices. This is example of point-to-point communication. You have workstation 1, workstation 2, and there is a link dedicated to serve them. It's just reserved for them to communicate over. No third-party node is allowed to transmit over this link except these two workstations. You have also links via satellite communication, via links with servers, with data centers. This is, we call it point-to-point communication. Now, how do you compare this with multi-point connection? Multi-point connection, it's also called multi-drop configuration or broadcast connection, is when you have one node communicating to multiple nodes at a time. In this connection, two or more devices share one link, which is connecting all of them together. Since more than two devices share the link, the capacity of the channel is shared now. So, what does this mean? In case of point-to-point connection, if the internet of speed of this link is 10 megabit per second, the two nodes will get 10 megabit per second. But if you are sharing the media with multiple devices, then the speed of the media will divide it by the number of devices. So it means the more computers you add to the network, the lower the data rate will be for each user. Example of multi-point connection is this. You have mainframe, which is data center or server, and you have multiple PCs, and all these PCs are connected via one link, one media. So the speed with respect to each node will be lower than the case of having just point-to-point connection. Link layer services. So in this section, we will talk about link layer services, and the objectives here are to know the various services offered by the data link layer, understand the services offered by the data link layer. So as we mentioned before, we briefly explained the main functionalities offered by data link layer, and we said the data link layer is responsible for moving data frames from one node to another node. Services provided by data link layer can be listed as follows. 1. Framing. 2nd, physical addressing. 3rd, flow control. 4th, error control. 5th, access control. As you can see, all of them control. That's why they call it link control sometimes, data link control. So we will understand the meaning of each one of these and be able to give examples on each one of them and how they work in a computer network.